Welcome back. This is the third and likely final segment for section 7.2. As you'll recall, in the previous segment, we looked at the situation where the known, for a side-side angle scenario where the known angle was obtuse, that we knew that broke down into a couple of different solutions, or either no solution if one side is too short, or a single solution if it's long enough. So what we're going to do in this segment is we're going to kind of do something very similar, but except this time we're going to start with an acute angle, and I'm going to kind of show you the situation where we end up with no solution and what that looks like. And then I'm gonna transition to a situation where using the same triangles, I want some of the setup to still be there. I don't want to spend too much time recreating everything. But another situation where the other side produces two solutions and how to approach that. This may be a little bit of a long video, but I think this is enough for the topic. So I want to get rolling here as soon as possible. So let's see, I think we were on page 3, so now we'll be on page 4. So let me set up a situation where there's no solution. So let me say given, and it's the standard sort of setup with the triangle, you know, A, B, C. I don't think it's really relevant to rewrite this, but let's say that we have C is equal to 38 degrees. So this is our acute angle situation. And the opposite side, let's make that equal to, let's make it 58. And one of the near sides, let's make this 108. And they can have units. I mean, that's not really totally relevant, but they usually do have units. So maybe just a quick draft here. So here's kind of the situation. Here's little c, there's A, and there's angle C. So the first step in trying to solve this problem is to try to, if you didn't recognize that this was a situation that doesn't work, how would you find out? Well, you're going to want to compare side C. So how does C compare to A times sine of C? Well, let's just simply calculate A times sine of C. Remember, this is the altitude, right? The altitude of this triangle, at least from this perspective, is this quantity. So A times C is equal to, 108 times the sine of 38 degrees. So 38 degrees sine of 38 times 108, and we end up with 66.49 and some change. So what does this tell us? Well, the altitude is actually longer than the opposite side. So this immediately tells us that this there is no solution to this triangle, and there's no point to continuing. So no solution, and the reason why is that C is strictly less than A times sine of C, and that's on our little flow chart. That's the reason why, right? And we would be done because there's no triangle to be solved. That's kind of uninteresting though. So let's use the quantities that we have here and pick a side length that will actually work. So it needs to be this 66.49 yada yada yada. That is, if it was exactly that length, then it would be a right triangle, which is why I was saying it's kind of hard with measurements to actually end up with anything that's a perfectly right triangle. So if it's somewhere between 66 and a half and 108, then we end up with two solutions, and that's what we're interested in. Because if you get to If you get to the situation where C is actually larger than A, you're back to one solution, and that actually kind of gets confusing. So let's say, let's change to C equal, and so we need it to be a little bit more than 66.5. Let's say it's 82. That seems like a reasonable number. Okay, so now note that C is less than A, but it's also greater than the altitude of the triangle. So 2 solutions. Now, how do we find the 2 solutions? Well, let's kind of draw, since we know that we've got a situation where there are 2 solutions, let's just go ahead and draw that now. So we've got, so there's our A value. There's our angle. So this was angle C. This is A. And we've got sort of this situation. That's one value. Let's call that, I mean, that's C. And this will be, let's call this angle A1. This is usually how the textbook does it. They make little subscripts. So it's like, well, here's, you know, the first solution, and then you'll have a corresponding, got to be real careful here because B actually takes on 2 values. So B1 is the whole thing. And if there's another possible solution, it will form an isosceles triangle here. And we would call this, so the whole length we would call little b1. And then this in here would be angle A2. This would be length B2. And this angle up here is B2. So that's kind of the setup for just describing how to kind of note what these are. So finding the first one is the easy one. And that's because of the technique that we use. The law of sines, pretty straightforward, will give you this result. So let's take a look at this. So we're now in section 7.2, and this is page 5. So what we're trying to do first in every situation involving side-side angle is we're trying to find, we have this pair, so to speak. So we're using the law of sines to investigate this pair. The numbers that have no subscripts are fixed. They're in the problem. So the first thing, let me just go ahead and write out the law of sines for that, that triangle. So sine of A1 over A is equal to sine of C over C. And we want to find A1. So sine of A1 is equal to A over C times sine of C. And this will be in the range. This will be a number less than 1, but it'll be positive. So then, since the next step is to take an inverse sine, ask yourself the questions that we asked in the in chapter 2. We said, is it in the range? Yes. There are 2 solutions. One of which you can achieve by taking the inverse sine, and the other one is by a quadrant argument. So the question being, this is going to be a positive number, so there is an answer in quadrant 1, and that will be produced by taking the inverse sine. But there's also an answer in quadrant 2, because remember, sine is positive in quadrant 2 as well. That's going to actually be our second solution. But this one, like I said, is relatively straightforward. So A1 is equal to the inverse sine of A over C sine of C, which is the inverse sine of, and let me get my values in here. So A was, when we modified it, it's 108, and C was 82, and then it's times the sine of C, which was 38 degrees. Okay, so calculating this fairly quickly, we have 38 sine times 108 divided by 82. Notice this is a number less than 1, positive. It's in the range of signs, so we can take the inverse sign with impunity, so to speak. And there's our angle. So this is the acute angle, 54.18113.866, etc. And that's in degrees. So I'm going to go ahead and store this because I'm going to use it one more time. Because now that I have A1 and I have angle C, I can find the third angle. And now I'm back to a situation where actually I have angle, side. And in fact, it doesn't really matter which side I pick. So angle B1 will be equal to the 180 degrees minus C minus A1. And remember, I have to use this kind of crazy angle here. So this will be 180 degrees minus 38 degrees minus 54.18113 whatever. And the result that I get, and I'll go, since I've got it already on my calculator stored, I'll take 180 minus 38 minus recall 1. And there's the angle, 87.81886 and some change. Okay, so it turns out that in order to find the third side, this is the angle I actually need, right? So this is a number derived from calculation, derived from a previous calculation. I want to hold all the decimal places I can because I don't want to round this at all. And so I'm going to actually store that as the second unit. So again, just like I did in the previous example, I have angle 1 is, or sorry, A1 is in memory 1, and then angle B1 is in memory 2. Okay, so the final task is to find length of B1. So B1 is equal to, and I want to use the original pairs, so C sine of B1 over sine of C. That's just a rearrangement of the law of sines for the appropriate side that I'm looking for. So this is, C was, again, 58. And B, so sine of this crazy 87.81886, etc., over the sine of angle C, which was 38 degrees. And this is why I'm storing this, because I'm going to use it. I mean, I could have it on the screen, but so I'm going to take the sine of that angle and divide it by the sine of 38 degrees, and then multiply that by 58. And I end up with 94.13936, whatever. Okay. And I will apply the rules of significant digits at the end. So the next step is to focus back on this step right here. Okay. When I went from here to here, I found the acute angle. If we look back at the diagram, we know that there's this obtuse angle solution as well. Now, how do we find that obtuse angle? Well, as I mentioned before, if you just look at that triangle, right? If you just look at that triangle, this is an isosceles triangle because both sides are equal to, both of these sides are equal to C. So these base angles are equal. This is A1. So the relationship between A1 and A2 is that A1 is this, A2 is the supplement of A1. And it turns out that when we go into solving trigonometric equations, you're going to get real familiar with how to work with inverse sine solutions. So basically, it is the supplement of whatever this number comes out as, and that's the value. So we just simply take the supplement of that, and we'll end up with A2. So to put that into something where you could sort of write it down, so let's see, section 2, I'm now on page 5. So going back, and that's why I've kind of used different labels so that you can see what's going on. It's the same equation, right? It's sine of A2 is equal to, and you recall it was A over C times sine of C. Now, what we did before is just say we'll take the inverse sine of both sides. Here we need to take the supplement. And in fact, it turns out that with any time you're taking an inverse sine to solve a problem, that there is a second branch. What we had before, the inverse sine, is what's called the principal root. Just sounds very similar to square roots, and that's intentional. Then there is the alternate root. And for sine, the alternate root is the supplement. So A2 is going to be 180 degrees minus the inverse sine of A over C times sine of C. Now, note, I already have this stored in my calculator. That's actually A1. Right? That's A1. And so what I'll do is I'll just subtract A1 from 180 so that I've got it pretty easily. So I can clear 2 because it won't matter anymore. I don't need B, but I do have A. So I've got A1 is stored as memory 1. So 180 degrees minus angle A1 gives me angle A2, which is 125.8188613 degrees. Okay, and I'll go ahead and store that as angle 2. So now memory 1 is angle 1, A1, memory 2 is angle A2, and I'm going to end up with a B2 here in a second. So B2, just like before, is going to be 180 degrees minus C minus A2 now. So we have 180 degrees minus 38 degrees minus 125.8188 yada yada. So let's see, 180 minus 38 minus recall 2 now. And there's our answer. We have 16.18113.866 degrees. So again, like I did before, because I'm going to use this angle, rather than doing some approximation, I will just store that as memory 3. So again, memory 1 is angle A1, which is no longer necessary. Memory 2 is angle A2, and memory 3 is angle B2. So then when I calculate it, I've got no problem. From here on out, it's exactly the same calculation. So B2 is equal to C times sine of B2 over sine of C. Because I'm getting a little tight on space here, is going, and I kind of want to end on this page, 58 times the sine of B2 up here, which is 16.18113 whatever, divided by the sine of 38 degrees. So recall 3, remember that's our angle B2. We take the sine of that divided by the sine of 38 and then multiplied by 58 gives me 26.25330 whatever. Okay, so now to summarize what we have for the two solutions, right? We have angle A1, which going back to A1, I know it's just a second ago. Remember, the digit of significance is here, so this will be 88 degrees. For B1, oh, I'm sorry, I had that messed up. This is 54. B is actually 88. C was given in the problem as 38, and you can verify that these add up to 180. A was given in the problem as, what was it given as? Sorry, A was given as 108. B was given as, in our second version, sorry, B was calculated, this is B1. B1 was calculated here. It should have 2 digits of significance, so 94. And it doesn't have units. I mean, it could be feet, meters, whatever else. And then C was given in the problem as 82. Now, what changes? We just need to have some subscripts for the 2's. So A2 is here. It's calculated. Remember, the digit of significance is the degree. So 126 degrees. B2 calculated here. Digit of significance is the degrees, so 16 degrees. And then finally, we have distance B2, which was calculated 2 significant digits, 2 significant digits, a calculation that only has 2 significant digits. So B2 is equal to 26. So there's our combined 2-triangle solution. And usually from in a situation where this might be like an application where you're actually trying to solve a triangle like this, it's usually pretty obvious which one's which, because you can either tell by looking either that second angle is acute or that second angle is obtuse. And so being able to recognize that there are 2 possible answers is the secret to being able to decide which solution is relevant. Because as a general rule, sorry, this was page 6. As a general rule, you know, you have to apply some sort of critical analysis of any sort of application. Say, does this make sense? And it wouldn't make sense if you started to calculate and come up with an acute angle when you can verify just even visually that the angle is obtuse. I have seen this come up several times. It's something that maybe should be emphasized a little bit more. But for the most part, the ambiguous case is not super prevalent in applications. Sometimes it happens. There's good reasons to not make a measurement this way, but that's probably a discussion for maybe a different kind of class, depending on the sort of situation, because there's something called strength of figure, which makes it's a sort of a measure of how accurate those other distances are going to be based on whether you have sort of an acute angle, an obtuse, what pieces and parts of the triangle do you have. That has more to do with error and really is beyond the ability to discuss in this class. So, okay, this this will end section 7.2, and I will see you back again for 7.3.